So actually, the first question here is whether local SOC alerts can be shared without losing operational meaning. So this is very critical because an alert is not only a JSON object or a line in the database. For SOC analyst, it is a decision point actually. So what happened, where, how serious it is, and what actions may be needed. So the second question is whether the heterogeneous CMs can be understood in a common way. In real environments, organizations do not all use the same CMs, the same alert model, or the same naming conventions. Some SOC may have a Splunk, for example, other QRadar, another RSA, and someone have some other market available CM. So if we want to understand the situational awareness, the central layer must understand these alerts in a comparable way. So the third question is whether central monitoring can help detect patterns that one SOC may miss. This is one of the major benefits of the architecture. A local SOC may see one incident and treat it as isolated, but in a similar incidents are visible across several SOCs, the same event may become a part of coordinated campaign, as we have seen. So analysts need to know whether an alert is a new or under review, updated or closed or replaced by some new alerts. So if the life cycle is unclear, the central view may become confusing. So from the pilot side, we are not only testing data movement, we are actually testing whether the shared alert can still support the real operational decision. The first practical obstacle is that local CMs do not speak the same language. So the schema should be read from the left to right. So on the left, we have the different local tools, SOC tools. They are detect the security relevant situation, but they do not represent them in the same way. For example, Splunk and this operational object is typically a notable event often produced by the correlation researches and can relate to contain rich content, rich detection logics, rule names, descriptions. For IBM, the concept is different. The QRadar uses the offences where the offense groups the rule matches. So we, even before we standardize anything, the native object is not the same in all the CMs. For example, with the RSA in its own incidents and alert models. So this doesn't mean one tool is better or the worse. It just means that each CM reflects its own internal logic and operational model. So the middle of the schema is the key point. SAFE4SOC translates these different local objects into the IDMF v2 shared alert. This is a common representation. The value is that the central SOC view does not need to understand every CM-specific object in a native form. Instead, it receives a standardized alert that can be compared, filtered, and displayed. So this is very important for the end user because it avoids forcing every organization to change its local CM. The local SOCs can keep their existing tools and processes while shared layer creates a common language for the cooperation. But the transition and the translation alone is not enough. The shared alert must preserve the operational meaning. So the central object is the shared alert, but the shared alert is useful only if it still answers the basic questions that SOC analyst work would ask from the local CMs. First, like what happened? This is the represented through the category and the description. The category is especially important because it is one of the fields that enable central correlations. If the same attack is categorized differently by the different CMs, the central layer may fail to recognize the alerts are related or not. The description is also important because it can help analyst and AI component interpret alert when the category is not sufficient. Secondly, where it comes from. This is a source. It may be an IP address, a user, a host, a sensor, a drone, or another detected entity. So depending upon the type of the incident, of course. So if the source is missing or badly managed, the analyst loses an important part of the investigation context. The third, what was affected? This is the target. In the cyber case, it may be a server or account. In a physical or availability case, it may be a building, a device, camera, site, or a service even. The target information is essential for understanding scope and impact. The fourth is how serious is it? Like, this is the priority. Different tools may use different security models, but the central platform needs a common way to compare operational importance. If what is the current state, this is the life cycle or the status, an alert that is open, updated, or closed. So this needs to be interpreted in the same way. So this is why lifecycle is a part of operational meaning, not only a technical field. So this brings us to the practical lifecycle, how an alert moves from a local detection to a shared awareness. I will follow 5 steps exactly like as shown, like detect, normalize, share, review, and update. The first step is detect. The local CMs create an alert object, for example, Splunk notable event, a QRadar offense, or incident. So at this point, alert will belong to the local SOC environment and follow local rules. The second step is normalize here. Local fields are mapped into the IDMF. This includes the attributes such as the time, source, target, category, description. So this step is where the meaning can either be preserved or lost. If mapping is weak, the central alert may be difficult to interpret later. So the third step is share. The gateway sends the allowed information towards the central layer. This is not uncontrolled data sharing. The sharing parameter must be agreed. Filtering, anonymization, pseudonymization, and policy constraints are part of the process. This is important for the end user because many SOCs cannot simply expose all the local data. The fourth is review. Once the alert is visible centrally, it can be reviewed by a central operator or by the analyst working with the broader view. The goal is not to duplicate local SOC work, but to add the second level of awareness. Is this alert isolated or does it match something happening elsewhere? So the fifth step is update. This is where lifecycle consistency matters. If the local alerts changes status, if it is closed, if it is replaced by a new alert, or the new information becomes available. So the central view must remain consistent. Otherwise, the shared platform risks showing the state or misleading information. So the life cycle is not just the technical pipeline. It is the operational part that allows local detection to become shared awareness while keeping the analyst trust. The final question is, what does this give to the end user in practice? So here, the final, I would say it is a structured as before and after what is difficult in practice today and what SAFE4SOC enables. First, before this kind of architecture, each SOC mainly sees its own alerts. So that is normal because SOC are usually designed for the local monitoring, but the limitation is that a local SOC may miss the broader pattern. SAFE4SOC enables shared situational awareness, like selected alerts from the several SOCs can be seen centrally and interpreted together. The second, SIEM formats are different, as we saw with the Splunk, the QRadar, and the different other market available SIEMs. The same operational reality can be represented with different native objects and field names. So SAFE4SOC enables a common IDMF alert representation so that the central layer does not depend on one vendor's specific model. So the third, cross-SOC patterns are hard to detect manually. A single SOC may see a medium priority brute force alert, for example, Another may see a VPN-related activities. Another may see the similar campaign indicators. Alone, each case may look like a local event, but together they may reveal a coordinated campaign or recurring attack pattern. So SAFE4SOC makes this kind of comparison possible at the central layer. So further sharing may expose too much data if it is not controlled. For the end user, it is a very serious concern. So the architecture therefore needs filtering and an agreed sharing parameter. So that's the local SOC keeps control over what is shared. So the fifth one is alert meaning may be lost when the data moves between the tools. This is why mapping is not a secondary documentation task. It preserves analyst context. For example, the categories, the description, the source, target, priority, and even the life cycle. So the main message is SAFE4SOC doesn't replace local SOCs or local SIEMs. It adds a trusted sharing layer above them. Local SOCs keep their tools in operational control while the central layer adds cross-SOC visibility, correlation, and early warnings for the CISOs and government cybersecurity organization, MSSPs, and the critical infrastructures operator. That is a practical value. Control sharing, common understanding, and better situational awareness across the organization. To summarize, it is an operational alert must preserve meaning, life cycle, and analyst trust when move from local SIEM to the shared central view. So SAFE4SOC addresses this by translating heterogeneous SIEM objects into the common representation, sharing only the agreed data and enabling the central correlations for the patterns that one SOC alone may miss it. So that result is not replacement of local SOC, but a controlled layer for shared situational awareness. Thank you. That's all. I will hand over to Valdez.